Mira. Ese. Bueno, yo creo que estamos listos para empezar. Ustedes en presencial me avisen, por favor, cuando estén conectados a la última liga de YouTube que les mandé. Por favor, Marco, me avisas. Bueno, todo listo. Perdón por el pequeño retraso. Te voy a pedir a Dan, por favor, prender su cámara. Y también María. Y María, por favor, puedes presentar el doctorado. Y ya voy a empezar a grabar.
Muy bien, buenos días, bienvenidos a esta tercera sesión de
Recording in progress.
Vamos a iniciar con la lectura del doctor Adán Guerrero. Él es un científico mexicano adscrito al Laboratorio Nacional de Microscopía Avanzada del Instituto de Biotecnología de la UNAM. Ha sido fundamental en el desarrollo de la comunidad mexicana de bioimagen, promoviendo programas educativos nacionales e internacionales y participa activamente en Global Bioimaging, Latin American Bioimaging y de Norteamérica es parte del comité directivo de Quaret Limit, que fomenta estándares internacionales en microscopía óptica. Gracias, doctor Adán. El día de hoy nos va a presentar LATAM Bioimaging.
Buenos días. Muy buenos días a todos, es un placer estar aquí. Esta presentación la estoy dando en representación de la doctora Lía Pietrasanta, quien no nos va a poder acompañar. A continuación voy a correr las diapositivas. Un segundito, estoy tratando de ver que corran. ¿Se está viendo que están avanzando las diapositivas? Listo, ahí está. Entonces, Bioimaging en Latinoamérica, o Latin American Bioimaging, es una red colaborativa que fomenta el desarrollo del campo de la bioimaging en América Latina. Es una red que aborda necesidades en el campo de la bioimagen, que incluyen la formación, el entrenamiento, el acceso abierto a tecnologías de imágenes en las regiones de América Latina y el Caribe. En específico, es una red que integra personas, integra científicos, expertos en el campo de la bioimagen, que incluye la microscopía, el análisis de imágenes, la imagen médica, desarrolladores de tecnologías y empresas. Coordina, en términos generales, la red para fomentar el desarrollo de la comunidad y también de las capacidades. Promueve la integración de la comunidad a nivel internacional. Actualmente, Latin American Bioimaging cuenta con 381 miembros en total, de los cuales la mayor parte son residentes en Latinoamérica. En este momento aborda a 28 países en total, 13 de Latinoamérica, y como podemos aquí ver en esta representación, son los países que tienen mayor representatividad, incluyendo México. Tenemos 63 miembros en México. La gobernanza actual del ABI está formada por un coordinador saliente, una coordinadora y un coordinador alterno, y con representantes de los distintos países que conforman la red. Entonces, la ABI es una red para construir. En la ABI construimos capacidades, construimos comunidad y promovemos integración global. Hay varios ejes de incidencia en la ABI y los voy a describir a continuación. Uno de ellos es la creación de una plataforma centralizada y actualizada de oportunidades y recursos. Los invito a que visiten nuestro sitio en internet, donde van a poder encontrar información acerca de eventos, cursos, talleres, ofertas laborales, recursos de formación que están disponibles actualmente, digamos, en el campo de la bioimagen, en sus comunidades, en México, en este caso en México, en América Latina. También lo que se cuenta es un mapa, una coordinación, donde uno puede identificar dónde hay unidades de servicio en América Latina. Este es, digamos, el mapa que tiene esta representatividad. Como pueden ver, es muy útil porque ustedes pueden identificar dónde es que hay infraestructura disponible en su región. Otra de las actividades seminales del ABI es construir capacidades. Entre ellos tenemos el apoyo para programas de formación y desarrollo profesional, como aquí tenemos los talleres del ABI, donde tenemos 3 categorías. El ABI otorga becas para personas que están interesadas en asistir a cursos de bioimagen, como en el que se encuentran actualmente en Ciudad de México. Está destinado a usuarios y investigadores. Hay asistencia a cursos de bioimagen, pero esto está destinado a personal de unidades de servicio de bioimagen. Y aquí es bien interesante, porque las personas que trabajan en unidades de servicio, unidades de microscopía, están ahí e interaccionan con muchas personas. Entonces, lo que se trata de hacer en esta distinción entre categorías es que el aprendizaje que se genera puede impactar al mayor número de personas. También hay otra categoría que es el desarrollo profesional y conexión de centros de imagenología en América Latina. Es decir, este apoyo es para realizar un intercambio de experiencias, que una persona vaya a otra unidad de servicio y aprenda técnicas que no tiene actualmente en su unidad o viceversa. En total hemos tenido 27 postulaciones que han sido financiadas, que incluyen 7 países. En la primera ronda de financiamiento se becaron a 7 personas. Tuvimos gente de Colombia, de Chile, de Uruguay, de Argentina, de Brasil, que estuvieron migrando entre Argentina, México, entre esos países, y en la segunda ronda tenemos más becados. Aquí lo que podemos ver, la última ronda, que fue este año, se becaron 11 personas para estas actividades de movilidad, y actualmente está corriendo el próximo llamado. Creo que hubo apoyos para asistir a la reunión anual de Latinoamérica y vamos a tener más convocatorias abiertas muy próximamente. Otro de los elementos que se aborda en la ABI es a través de sus grupos de trabajo, que es tratar de identificar y generar planes de acción para atender las necesidades regionales mediante la colaboración de las personas que nos encontramos ahí. Entonces, en los grupos de trabajo actualmente están en la ABI, está el de gobernanza, que está encargado en organizar la reunión anual. También en el grupo de trabajo que está enfocado en cómo generar incidencia regional en la sociedad en general. Hay otro enfocado al entrenamiento, y vamos a ir creciendo el número de grupos de trabajo. Hay necesidades que se encuentran ya muy claramente identificadas, como el tema de análisis de los datos que se generan en la imagen, entre otros. Dentro de estas actividades, por ejemplo, acaba de ocurrir en Argentina, en Argentina, perdón, un evento que se llama Train the Trainers, donde se reúnen expertos en microscopía para compartir experiencias y mejorar las capacidades de enseñanza en términos de microscopía. Muy pronto vamos a tener en Río de Janeiro el evento que va a ocurrir en colaboración con Global Bioimaging, que se llama Facility Management. Este es un evento que está dedicado a personas que trabajan en unidades de servicio y la idea es empoderar y fomentar el uso distribuido de la tecnología que se encuentra y también reconocer las capacidades y impulsar el desarrollo de las personas que se encuentran ahí. Entonces es muy, muy interesante si alguno de ustedes trabaja en unidades de servicio, que estén al tanto de estos de Facility Management. Otra de las cosas que hacemos es promover la integración de la comunidad global y hacemos esfuerzos muy, muy fuertes en conectarnos con las comunidades en América del Norte, en Europa, en otros países. Y esto se genera a través de la organización de eventos, de reuniones satélites que fomentan la interacción entre las personas. Por ejemplo, este es uno de los eventos. Aquí esta es la presentación de las dos reuniones anuales que ocurrieron en el 2022 y 2023, donde nos juntamos para identificar cuáles son los retos que tenemos en cada una de nuestras regiones, en cada uno de nuestros países, y se promueve la colaboración para expandir esta red y identificar soluciones para los retos con los que estamos afrontando. Por supuesto, en todo momento estamos integrando cada vez más las interacciones con colegas en otras redes y como pueden ver, la Latin American Bioimaging ha estado creciendo. Nuestra siguiente reunión va a ser muy pronto, va a ocurrir entre el 18 y el 21 de agosto en Río de Janeiro. Ya cerró la convocatoria para los Travel Grants y hoy cierra, me parece, el registro a esta reunión. ¿Cómo involucrarse? Pues si alguno de ustedes trabaja en una unidad de servicio, de microscopía, de bioimagen en general, o si alguno de ustedes es usuario de esta tecnología, o si está interesado en adquirir capacidades que pueden ser tecnológicas, que pueden ser conceptuales, únanse a nosotros. Es una red que no tiene costos, sin fines de lucro, y está ahí para que nos apoyemos entre todos. Muchas gracias. Con eso termino mi presentación.
Muchas gracias, doctor. Si hay alguna pregunta para el doctor. ¿Alguien de ustedes, algún interés, alguna inquietud para que el doctor la escuche? Es muy interesante tal que ha dicho y pues para muchos es una oportunidad precisamente de seguir creciendo. Pues muchas gracias, doctor. Creo que no hay preguntas. A ver, voy a revisar en el chat, por favor. Dice que sí hay convocatorias para investigadores que están trabajando como usuarios de la microscopía.
Sí, tenemos esas convocatorias en Lavi. Si ustedes se meten en nuestro sitio de internet, las pueden identificar. Específicamente la convocatoria que ustedes están preguntando sería el número 2. No, perdón, el número 1, que está dedicada para usuarios e investigadores. Entonces sí, por supuesto que la AVI apoya que ustedes vayan a eventos en otras partes.
Preguntan que si también de usuarios de análisis de imagen.
Sí, también. Si ustedes están interesados en algo que esté relacionado a bioimagen, no solo en el tema de la colecta, sino también en el análisis, pueden aprovechar este tipo de oportunidades, por ejemplo, para una escuela internacional. Les doy un ejemplo. Hace 2 semanas en Cuernavaca, Morelos, tuvimos una escuela en coordinación con Global Bioimaging, para fomentar el desarrollo de las capacidades en términos de análisis de imágenes. Este evento, por parte de Global Bioimaging, se otorgaron una buena cantidad de becas, y también ustedes pueden tener acceso a estas redes para, en dado caso que no hayan tenido la beca de GBU, Global Bioimaging, pues solicitar con antelación, ¿no? También hay otras redes, por ejemplo, en México. México también forma parte de Bio en North America. Entonces, uno puede ingresar también a esa página, BINA, y identificar oportunidades que se encuentran ahí. Entonces, la respuesta es sí, contemplamos el análisis de imagen.
Muy bien, agradecemos sus respuestas. Vamos a pedirle a todos los asistentes pues que ingresen a la página para enterarse un poco más de las dudas que tienen, y pues le agradecemos al doctor Adán su presentación para continuar con las siguientes. Gracias.
Muchísimas gracias. Hasta luego.
Hi, Dr. Robert. Good morning. Can you hear us? Welcome.
Hello.
Hello. Buenos días.
Buenos dias. I'm sorry, my Spanish is like super limited. I'm good in German and in English, but yeah, it's like.
Do you know Dr. Adam? He's also here with us.
Not yet. Now we know each other. Hi.
And we were together in the Latin America, in the Napari Latin school.
Ah, okay. I see. Yeah, the world is a village during the weekend.
Nice to see you again.
Nice to see.
Yeah. So thank you, and sorry for the delay. We are now with some technical issues, but it's a big pleasure to have you with us today. And I'm going to do a quick presentation. And that's it. Adan, you are invited to stay, of course, to watch. I'm going to remove you from Spotlight. Done. So,
I shall share my screen.
yes, please.
Awesome.
So, everyone, Dr. Robert is a computer scientist by training and follows his curiosity deeper and deeper into data science and life science. He received a PhD from Faculty of Medicine Carl Gustav Karus of the TU Dresden in Germany, right? For his work on swarm intelligence based algorithm for medical image segmentation in the cancer research context. He served as lecturer for bioimage analysis, biostatistics, and programming at the Biotechnology Center of the TU Dresden. His postdoctoral research in Jan Meyer's lab at the Center of Systems Biology and the Max Planck Institute for Molecular Cell Biology and Genetics concentrated on bridging the disciplines computer science and biology to forward understand how tissues and organisms form. And he headed the Bioimage Analysis Technology Development Group at the Cluster of Excellence Physics of Life at the TU Dresden II, where his team developed various bioimage analysis Python libraries. Today, he works as lecturer and trainee coordinator at the Data Science Center of Leipzig, my German is not good, University, and the Center for Scalable Data Analytics and Artificial Intelligence, ISCA-DS AI Dresden, Leipzig. Please, can you say the name of the city for us?
Of course. So thank you very much for the very kind introduction. So I was recently, like half a year ago, I moved from Dresden after being there for many years, and I live now in Leipzig. And the institute name, SCAT-AI, is also hard to pronounce sometimes, even for people from locals. So that's an artificial intelligence research center. So I work now in one of the 6 German artificial intelligence research centers, and that's why I have time to think about large language models for biology analysis. That's the kind of stuff I was doing before. So let me quickly guide you through the story. Large language models, I'm pretty sure that all of you, or the vast majority of you, have heard about this technology before. It's a form of neural network which can translate, for example, text. So you see here on that side, it's an English sentence, or a very short sentence, actually, open HeLa self-tif. And on the right side, you see a different language, it's Python. So a large language model can translate, for example, an English sentence, asking for something, can translate it to Python code, which eventually does that. So large language models can do a lot more things. I will also show some side topics, but I'm mostly fascinated about the fact that in English, in German, and I'm also pretty sure in Spanish, I could say, hey, please do this kind of analysis on my data, and the language model is capable of generating code for doing this kind of analysis. So that's very fascinating. So I'm a bioimage analyst, and you see here what my typical job is. So biologists approach me, show me their image data, and I help them to set up an image analysis workflow, for example, segmenting nuclei in an image. And it turned out that ChatGPT, the famous large language model we all have heard about, is capable of doing that. So when I upload this microscopy image to ChatGPT and I say, please segment the nuclei in the blue channel of this image, the image we see on the right, the segmented image, is the result. So it can also explain what it's doing. So it's like not just a random gap. So that's a very fascinating technology which had a huge development in the last 2 years. And there's another thing which is coming up these days, more and more people are talking about, is the so-called vision language models. It's basically a language model which can take an image as an additional input. And here you see what happens when I do that, when I use this one. And so I asked ChatGPT how many blue nuclei are in this image. Not asking for a segmentation, but asking for a number of nuclei directly. And it will then say, could, for example, say here there are 3 nuclei. That's obviously wrong. And I had this slide a couple of times in my talks. I was always making jokes about ChatGPT, how dumb it is. But actually, I am dumb because I was doing here like bad scientific practice. I was just asking the question one. And yeah, there is some variation obviously in there. So after some time, I eventually found the time to do this more systematic and to do it more scientifically correct. So I uploaded this time this image, and I asked, analyze the following image and count the bright blobs, respond with the number only. And I did this 25 times, and I did it with 3 different language models. So here you see how the company OpenAI, who is working on ChatGPT, who is further developing it, how they are modifying this technology, how it is becoming, let's say, more precise and maybe also more accurate over time. So with every new language model which comes out, or at least the last 3 language models, the last 3 vision models which came out, there is some development visible. So they are apparently working on this. So that basically raises the question or the need for this so-called multimodal language model. So we want to have text as input, we want to have images as input, and we want to create images out of it, and we want to get text out of it. And it would be amazing if this would work. So I think our technology is moving in that direction. But at the moment, when we look again at this screenshot, there's this little button there on the bottom. We can click on it. And you will realize that ChatGPT was not using a language model to answer this question. It was instead generating code. And that's what I showed at the very beginning. It takes English text and converts it into Python code, and then the Python code is executed, and we get an image analysis result because of this code which is generated under the hood. So that brings us back to this technology, and this is what we're using at the moment actually. So it's a bit, let's say, inconvenient to do this in the browser with the ChatGPT interface. That's why we thought, how can we have a technology that runs on our computer locally, on my workstation or on my laptop, so that I do not have to upload my image data to the OpenAI server, which has also some additional capabilities like this multi-agent capability and using vision model. It should also be extensible, and we want to integrate it in the Jupyter platform. I guess the people among you who do know some Python programming have heard about the Jupyter platform. And that's why we developed, well, So Bob works like the following. You have a Jupyter notebook in front of you, and you can say here, percentage Bob, load the blob.stif file and show it. And then Bob will generate code for you. It will also say that it's going to generate code. And then you can execute this code and it will visualize the image. So it's a very, very simple approach of how to use this interface. It's locally running on your computer. You enter a prompt. In the background, the sentence is sent to the OpenAI server, but the data, the image data, stays on your local computer, and the execution of the code happens on your local computer, which makes it quite different. You can also use it for more complex tasks. So here you see how I'm asking, hey, Bob, please open the blob's grayscale image, then segment the nuclei like object, use O2's method and connected component labeling, measure the area of the segmented cells, and print the area of each cell on top of the cell. And then it generates again code, which is more complex in this case. And it can also show the results quite nicely. So it's not just capable of solving simple tasks, also more advanced stuff is possible with this technology, which is again just highlighting that an invention of the OpenAI company. It's not that I made this possible. The language model is from this company. You also pay for it when you use it, and it works quite nicely. And we can get one step further forward. We have in our community a bit the issue that many biologists do not speak Python, but Python is unfortunately the language for data analysis, for deep learning, for statistical analysis, for image analysis. You can use Python, it's great. And we have a bit of an issue in distributing the Python knowledge into the community of biologists to make them learn Python so that they can analyze the data themselves and do not always need an expert like me. And therefore, we developed the following. You can also communicate to Bob directly and say, hey, Bob, I'm a Python beginner. So whenever you write code, please write it in a way that I get it. And then I asked Bob to generate a notebook which loads a CSV file. It's here German weather data, but actually off topic from an image analysis point of view. And I'm asking for a couple of tasks. I would like that Bob visualize the data, summarizes the table, does some statistics to measure the mean and maximum temperature, also do some plotting and so on. So I have kind of a list of things, and I asked Bob to do this and to do it in a notebook. So Bob will generate a notebook. So you find here there's some introduction at the beginning of this notebook, a disclaimer, this code was generated by AI, please be careful executing it. And then there's all these intermediate loading processing steps, including the plotting, and always some explanation on top of the code, because I told Bob that I'm a Python beginner and I need some additional explanation because I would like to learn how to do these things myself. And these kind of tasks, tables, plotting, Python and ChatGPT are amazing. Yeah? So even better suited than for image analysis. That's why I'm providing this example here. You can ask also Bob to generate training materials for you, for your particular purpose. I would like to learn this. Please show me. And it can do it for you. So what I've shown earlier is the vision language models. I also would like to show how you can use it from Bob. So that would be a kind of use case. So I'm now providing Bob with an image, and I say, what is in this microscopy image? Please answer in one sentence. And it would then say, this microscopy image, you see cells with blue stained nuclei and green stained cytoskeletal structures. That's half right. So the nuclei aspect is correct. I think green shows mitochondria and not cytoskeletal structures. But anyway, I can also ask Bob, what would be a deep learning-based algorithm that could segment the nuclei? And Bob would, for example, answer that you can use cell phones for this. Maybe it also answers status. So there's a couple of options it could reply to. And if I then ask Bob, can you please write code which applies this algorithm to my data? And again, that's what Bob can do. So thanks to the fact that I can put in an image, I can also let the vision language model look at the image and then generate code which suits better to the image than if it would not see the image, because it can tell us which algorithms are good for that. So here at that point, and also the computer scientist would, for example, say, yes, that's good code for applying deep learning to this particular image. And I hope it's helpful. I hope it makes sense. And you can combine, of course, both. You can also ask Bob by providing an image. Again, this works like this. You put it behind the Bob, and then you say, here, can you please write a new Jupyter notebook for this particular image the file name is this and that. At the beginning of the notebook, please explain what's in the image. The language model has to do this, because if it should afterwards generate code for processing the image, it has to write down in the first step what is in the image, because otherwise it will not actively perceive the image. It will just generate random code. And again, at the very end, please explain what you're doing in detail. I'm a Python beginner. So when you are a Python beginner and you use this technology for the first time, I highly recommend adding sentences like that, because then it will be more explanatory. Yeah? So when you see here that there's a notebook generator, Depends does not use cell pools, it's using the traditional classical image processing, but it is setting up an entire workflow for segmenting the image, and it does it in a notebook that you can follow step by step what it's doing. Also quite common in the community, and here like shame on us computer scientists, we sometimes write notebooks which technically solve the problem, but then there's no comment in between and nothing, super bad documentation. So that we do this, some of us do this because we're lazy. So we can now ask the language model, here, Bob, can you please open this notebook and put some additional explanations in between? And here also, I bet if you ask Bob to write these explanations in Spanish, it would certainly do it. So please try it out and also let me know how this works in Spanish. I would love to see. So it can add comments in between the code, and it can explain the code for those who are not so like super hardcore scripting people like me, for example. I was doing research in GPU acceleration before. So if you process images which are big and it takes a long time, you want to GPU accelerate the code. You want to change the code so that it's faster. And the language model can absolutely do this, because it's also just translation path, this time Python to Python. So and if you do this, it's kind of necessary that you do some good scientific practice and you measure the result before and afterwards, and you compare. So you basically have to validate that the old code and the new code do the same. We wrote a book chapter about this at some point, so you can here click on this link and read about it. How does this work under the hood? I would like to show some details. So you see here that we basically, a prompt to the language model always starts with a sentence. We are first telling ChatGPT, you are an extremely talented bioimage analyst, and you use Python to solve your tasks. Then we look what kind of Python libraries are inside in the current environment, and we generate some code snippets for this particular Python library. So for example, if you have scikit-image inside, which is a common image processing library, Bob will then see such a hint how to open an image with scikit-image. So basically, and it's many of these hints. It's not just one; it's maybe 100 or something like that. So a lot of hints provided to the language model so that they know what the typical image analysis code for the microscopy folks. At the very bottom, we do some additional things. So we, for example, ask that it should first know what it's going to do. Basically, again, to think about what it does before it's doing it. Then we ask it to provide a step-by-step plan, so that a common procedure in this case, and then afterwards it's supposed to produce code. This all together is something like 6,500 tokens, and a token is approximately a verb. So we basically put a huge text in front of your prompt. So you ask one sentence, please do this, and then there is additional 6,500 words instructing the language model how to submit to the image analysis questions. And that's why the code suits quite well to what you are doing. So that's kind of a nice technology. I've shown it a couple of times on conferences here and there. Also on YouTube, I think there's a video. And again, I have similar questions then afterwards coming up. So for example, which language model should I pay for? Is it ChatGPT, which is the best, or are there alternatives? Because there are no many out there. For example, is GPT-4o better than Claude? Or do LLMs influence the buyer? Can LLMs according to good scientific practice? So how can we validate the result of a language model without ground truth? Where's the technology? Where's the limit of this technology? And will we all be replaced by AI soon? Yeah, and questions of validation. So this all is basically around the question, how good are large language models for bioimage analysis? And I heard this question a couple of times, and I always wanted to know. I also wanted to have a kind of a quantitative measure to answer the question like a scientist, like properly. So that's what we did. So we started writing down common use cases. For example, here you see at the very beginning, there's a prompt. So it's basically a Python function, and then a comment below the so-called docstring documentation of this function. So this function implements a workflow consisting of these steps: threshold intensity of an image with Otsu's method. Then we label connected components. We measure the area of all the objects in the image, and we determine the mean area of this image. So this is basically a prompt which sent to the language model. Then we have some reference solution that is code written by a human. Me, for example, I wrote down this code, which does what is written on top of it. And then we have some Python code which tests if this function is actually doing the right thing. And we formulated 57 of these use cases. So we basically formulated those, sent them to a language model, get the code back from the language model, execute the language model generated code, and see if it's correct. And here the use case again, we start from an image, we binarize it, we label connected components, we measure the area, and we compute the average area. And if you ask different language models, and then you test, for example, we ask 10 times, and then we test how often it runs, you see down here on the bottom that GPT-4 is capable of solving this problem in 9 out of 10 cases. And Claude, that's also a model from a company in San Francisco, does it in 10 out of 10 cases. And for example, here, Gemini Pro, that's from Google, and there's Code Llama, which is an open source language model. So it's not as capable as the big companies. And there are more use cases. So here you see, for example, a use case for completing the correlation matrix. This is the single line Python code. Those who use pandas know it quite well. And you see here at the bottom that also the language models are quite capable of solving this particular task. This is, from my perspective, less challenging task, which was apparently complicated to solve for the language models. So I have a folder of images, of segmented images, and I would like to load these images one by one, and I would like to count how many objects are in there, and then provide this list of counts. And you see here that GPT-4 was capable of solving this problem in 1 out of 10 cases, and Claude never managed it. And also Gemini and Code Llama were not capable of solving this particular task. For whatever reason, we do not know. So I could now go further. There's again 57 of these cases. I'm just grouping some more to give some insight of what I think I see here. When you work with statistics, with tabular data, also with kind of summarizing tables, putting tables together, large language models are very capable of solving these kind of problems because the training data for the language model obviously contains this kind of use cases. If you want to do more image analysis specific stuff, like for example, measuring things and feature extraction, it becomes a bit more tricky. And if you do advanced things like working with big data, the language models have a very hard time in solving these kind of tasks. There it becomes really tricky, really challenging. So we submitted this preprint, I think in April or maybe in late March this year. Yeah, it was in April, I'm pretty sure. And this is like the language models we were comparing. And then there was new GPT-4 Omni, and then we could eventually try Gemini 1.5 for Google. And that was last week. A new version of Claude came out, and you see Claude is now at the moment leading our benchmark. It's the best model we have seen. But I'm also saying that the standard deviation, the variation from model to model is so big that you can actually not with confidence say that Claude is much better than GPT. But what you can say is that these two models from these two companies are leading our benchmark and are best capable of solving image analysis. We also looked a little bit into what kind of Python libraries they are using. You see, for example, here, scikit-image, Esperanto, Vedo, Dart. These are libraries we image analysts use often when we work with microscopy data. And yeah, the great is, of course, the question, if we should maybe come up with a bioimage analysis specific large language model, because what we use is a bit different from what the language models use. So maybe we have to adapt that. And we were also looking into common error messages they have. So you see, for example, here, there's this 203 here in the Gemini Pro column, and you see that's related to import statements. So Gemini Pro was again and again and again forgetting import statements. And you can also see that Gemini 1.5, the next version, did not have this problem anymore. So you can basically, by looking deeply into this data, you can see how the models are further developing, how they are improving over time, and you can study in very detail what they are capable of and what not. Just before I come to an end, just highlighting that the technology we developed and the language models we were working with, we are not alone out there. Like there's a huge movement at the moment, and you find many of these tools. Napari ChatGPT from Loic Royer, you may have heard about it. I think the paper came out last week or maybe a week ago. So that's a fantastic tool, which is exactly the same technology. It's just used a little bit differently, has a different interface. There's also Jupyter AI, which is doing pretty much the same like Bob, but does not have any bioimage analysis specific knowledge, and also a bit of different user interface, which was also capable of writing code for you. And the Bioimage.io chatbot is the website where you can go to, which can again provide nicely hints regarding bioimage analysis. So it's similar on that side, but it cannot enter code in your local Jupyter environment. Here it's different. So you see, there are multiple people working on this technology, making it available to the community in different ways. And at the moment, we have, I think we as a community, we have no idea what is the right way for providing access to the language models to the biologists or to the image analysts. So there's a huge movement in this space. Also, OpenAI itself, they came up at some point with GPT. So in the browser, again, you can have different solutions. So here, Antonius Newtas, I've never met him in person, and I would love to, develop the microscope image analysis GPT. I developed the bioimage analysis GPT. Also, these two GPTs solve the same problem, helping people with image analysis. And we are searching for the right way of doing this from a user experience perspective. So let me just summarize. Large language models are definitely capable of generating code to analyze microscopy images. That's pretty obvious. And I think if we have, for example, an open source benchmark that allows the community to measure which language model is how good, I also hope that the language model developers will take our benchmark serious and then at some point start developing language models which are better suited for our use cases, because then at some point we do not have to write Python code anymore, the language model will do it. The challenges are that we do not know exactly yet how to make this language model best suiting for our community. So there's a couple of techniques I have not mentioned here: fine-tuning, retrieval augmented generation, prompt engineering. Also multimodal, multi-agent systems are coming up, but again, we as a community do not know yet which of these technologies are best suited. And what I'm also very interested in, and I think I will also work on this in the future, is how to introduce good scientific practice. At the moment, we just let the language model generate code, but the language model does not give advice yet how to validate code, how to try out code in a scientific way so that we can be sure that the results of the code are correct. I would like to thank my collaborators from Leipzig and from Heidelberg, all the communities I'm part of, and my former group in Dresden, and of course the funding agencies. And I thank you for your attention, and I'm happy to take questions. Adan, you have a question.
Yes, can I make the question, or shall we?
Sure.
For the people in the presential. So let's ask Janaina. Janaina, shall I make my question?
Yes, we have one question from the public in presential event, but also please, everyone who has questions here can write in the chat for the Dr. Robert.
Or just robots, also okay.
Okay, Dr. Robert. So we have started using ChatGPT and these technologies for image segmentations, and a recurrent question that I have from my colleagues is, can I publish that? And will the editorials accept something that is generated with ChatGPT? How we should write the method section? So I wonder if you can develop some of these ideas and what is your vision about it?
Yeah, so but before we were working with language models, there was always, or at least for a couple of years already, code auto-completion. We were using similar technologies before, but they were not using artificial intelligence, was my classical algorithm. So I'm absolutely convinced that publishing AI-generated code is absolutely correct and should be done. I mean, we would waste our time if we would not do it. But what is really crucial is that whatever comes out of the AI system should be validated. You should at least, as a data analyst, you should at least read the code and make sure that you understand what it's doing and think about if this makes sense or not. If you find, for example, also a section of code where you do not know what it's doing, you can copy the section into ChatGPT and say, ChatGPT, can you please explain me what it's doing? And then you can go step by step to really make sense of the code. And then you should definitely publish it. So validation, I mean, validating code was a thing before AI. So we should have done it before anyway, but now we are eventually forced. And I think there's also more and more publications coming out today, thanks to deep learning, I must really say, where the deep learning experts show us how to do a proper algorithm validation. So we can take these learnings from that field, we can take over and apply. And I think what we should also do is we should, for example, in the supplemental material, we should also, at least to some degree, also publish the prompts we were using. So for example, if I was using ChatGPT with this and that prompt and it generated some code for me, I should share this knowledge so that the next generation can also take it over and can use similar prompts or modify these prompts to analyze their data. I think it's good scientific practice anyway to be transparent about how methods were applied. And then again, the validation step becomes more important. And I think it's great. That's a great development.
Thank you.
You're welcome.
Yes, we have one more question, and also you can see the camera of people in the other event. It's the same event, but we have like 20 people in Mexico City and 46 in online. So they are also listening to us. And there is some questions here in the chat, but one question from the public is from the Dr. Vadim. He's actually asking about the other options, like you're talking about Bob, but there is other open access tools like cloud, free options to use, because yeah, you are using ChatGPT, but probably it's one version that you have to pay. So do you have any free options to access this?
Yes. Oh, that's a very good question, actually. I could have shown another slide, but that's what I don't have to do today. So first of all, there are open source models, and you also find them in our benchmark, actually. The best language model, the best open model you can use, which you do not have to pay for, wait, an exception, is Llama 3. So if you download Llama 3 and let it run your computer, you can also use it, and it's almost as good as ChatGPT and Claude and all the other pay-for models. The problem is the following. If you want to use such open source model, you have to use a very powerful computer. So that's where the price comes in. So it's possible that if your institute, if your university does not have such infrastructure, you have to buy it, and then you pay something like $15,000, $20,000. So it's quite expensive to come up with such a solution. The smaller language models like CodeLlama, for example, it's also in the benchmark. You can run on your laptop, but it's stupid. It cannot analyze images, so it cannot help you here. That's why I would actually, even though it costs money, I would actually recommend going for one of the commercial solutions, going for OpenAI, going for Claude, and it can also give some insights into what you pay. If you, for example, so first of all, you have to register there, you have to get an account, and then you have to enter your credit card number. And then when you submit a prompt, for example, to Bob or to Napari ChatGPT, the same technology, US cent for a single prompt, or maybe half a cent or something like that. So if you use that, for example, during a week 10 times, you may have cost of something like 5 to 10 week and 20 to 40 cents per month. So it's not big money. So I can just recommend doing that because it's kind of really cheap, but also be careful. It's addictive. So I pay now between something like $5 and $30 every month. But also here I'm benchmarking these models. Yeah? So I run them 100 times to see which is the best. So that costs significantly more money. But if you're only using it, for example, for analyzing a handful of images, you may end up with something like $50 by the end of the month. So it's not big money.
Ai, Deus. Ai, Deus. Okay, thank you very much, Robert. Excellent presentation. So, you have few more comments in the chat. Please read and interact with our public. And thank you very much for your time and excellent presentation. If it's possible to send to us this presentation to send it to the attendees, to the students, will be amazing to read again and have access to this information.
The slides are online, and I posted a link in the chat.
Okay.
And maybe you can also distribute this link to the people in the room.
Excellent.
Thank you very much for having me. I will also respond to the one or the other question in the chat. And Ali, do you also have a question? Shall we quickly go for it, or are we out of time?
No, we have another presentation now from Dr. Martin. He's from Czech Republic, and he's already here with us. So I'm going to, yes, hi, Martin. Oh, 1 second. Oh. 1 second. I'm going to give you the permissions. Okay, Don, you can open your microphone and share your screen.
Oh, hello. Can you hear me properly? Is it okay?
Yes, we can hear you excellently.
Okay, it's good to hear. So I guess I can share my presentation and start, right?
Yes, Mari is going to do a quick presentation of you. So, Mari, please.
Yes, of course. Hi, Dr. Martin. I present. Yes, Martin Swash is a biomagic analyst based in Czech Republic, especially in biomagic analysis, biomedical signal, and image processing and open science. He holds a PhD in technical cybernetics from the University of the Chemistry and Technology in Prague and has additional training in data Swedish. Research project managed career managed leadership in research and advanced biomagic analysis. Active in organizations like Global Bias and the OSCE Association. Martin is dedicated to promote open access on the open data. He works at Open Access Microscopy Core Facility of Charles University, providing essential image analysis service to researchers, and has he hold roles such as data sphere and deputy chairman of the academic senate and his alma mater. His work underscores the significance of the open science in the magic analysis and the support provided by open access core facilities. Thank you so much, Dr. Meg.
Thank you for the introduction. I will share my screen and presentation. So is it okay?
Yes.
Yes, everything is okay.
Okay. So I can start. So thank you for the introduction, and also thank you for inviting me to give this talk. I think for this day in Word, I am presenting online, so it's quite exciting to do this. And what I will talk about is a little bit navigating the bioimage analysis landscape, the communities, and the collaborative dynamics, because it is very, very important for us together to collaborate. And I'm one of the examples that have to learn how all of this works. So I was thinking about a little bit introducing you also to my point of view and how I did go through all of this. Because I did go through something we would call, or I would call, the very classical engineering studies. And I started to focus on image analysis in 2015. But since I wanted to do something more applied, and I a little bit thought that the like straightforward engineering studies might not give me the opportunity to do all of this, I started as a bioimage analyst in neurobiomaging node in one of the bigger European nodes. I will talk about it a little bit too. But I didn't actually have the experience. I did know how to code. I did know mathematics and the things around. But what was the hardest for me was actually learn to communicate with the biologists and with the imaging scientists, because we each have a little different language. We use different words, and it took some time to learn this. So I later switched to a little like smaller node, because even in the bigger bioimaging node, there wasn't enough task for one analyst. And I actually didn't know about any of the communities or any of the people around that had much more knowledge. And I came first in the Notion advantages in 2019. And I actually personally consider that from that point of view, I started to truly be the bioimage analyst, because online in the world there's so many tools, so many approaches, so many workflows already done that I didn't know about, because there was no one who would tell me or would point me to any community or any knowledge base. That's I really didn't have a notion. So I consider myself to be truly the bioimage analysis for 2019, when I found out all the communities, and because of this, we even started our first bioimage analysis workshops. Where actually even Robert were part of, which we were very happy. And later, I started to be and try to help in planning for the other communities, and actually started Czech Bioimage Analysis Society, because I thought that the whole experience that I had to go through to get to the resources, that it's no reason why other people in Czech should do this. We're actually a very small country, so I wanted to promote all of this. So all the presentation, all the information I want to share with you now actually comes from all of this, all of my experience, and what I went through. So, but to start a little bit back, I also wanted to establish what we think is the bioimage analysis. Because the straightforward image analysis that a lot of time you can study is like a straightforward recognizing attributes in some image that usually is not even calibrated. So whenever there is a face in image, logo, or something else. But in reality, what we are interested in analyzing biological or medical images is that we actually want to analyze the shape, the intensities. We want all of these to be replicable and repeatable, and so on. So it's much more complex, and sometimes it might look like the task will be very straightforward, but we have to be very careful how we do our workflow, if we are able to explain it, and of course if we are able to validate what we are doing. And this is a little bit where it start to be tricky, because of course, like we can say, this is where the computer vision meets biology, and there is a lot of application where it already exists, like surveillance, biometric verification, or a lot of like straightforward medical diagnostics. But a lot of these things are repeated again and again and done in the very same way, which of course in science this is not all the time what we are doing. We are designing new experiments. We are really like testing the field, trying a new combination. So a lot of time we can get inspired, but we cannot very straightforwardly reuse some of the parts. So the expert domain knowledge is quite a critical, and we have to combine the knowledge of set of scientific fields. And in the end, at least for me, it comes to these three loops that can kind of a little bit reset each other in the goal, because each step will really make count what we can do with the results from the sample preparation to what kind of imaging methods we will use, how we set up the microscope, whatever we do, and what kind of digitalization we do, because we can always, or sometimes we can get to the part where we can see the data in image, and as a humans, we can see what the results should be, but then it's quite hard to analyze it, and we have to a little bit start from a scratch. And a lot of time, it makes sense to be able to design everything with help of other people, whether it is community or colleagues or core facility help. It saves a lot of data and saves a lot of time and saves a lot of resources, because all the changes on the go are quite expensive. Like all the experiments can sometimes takes months, and if we have to restart, then it takes a lot of resources. So one of the motivation for knowing the communities or about the colleague is also like setting it up and planning everything in advance in a correct and meaningful way. So, kind of best practice approach for this task is about the communication and how we can understand each other. Because from my experience, for me, for the computer scientist, at the start, like the tasks were very broad. They weren't specific, and for me, a lot of the questions were kind of fuzzy. And of course, for the biologists, from our point of view, I was overly reducing the complexity of the task to make it count. And of course, like we have to talk it through, and we have to figure out what the best approach or best tools can be. And this is also something where the communities or the collaboration can help us quite a lot. Uh, but good news and bad news, we already are quite good at doing this and communicate and engage in training school and but what it means, it is accelerating in a huge way how the development process is going. It makes the so huge that it's so difficult to interpret what's going on in the platform again, like sometimes so it is still very important for us to have some meaningful way where we can discuss this, because in the end, the stability and the reproducibility in all of these approaches are very important to what we aim to do. So that little bit comes to the bridging part of these two or three words in a science, and it is creating some communities. And I think most of you will be already familiar with the LBS and the LBS, the European Bioimage Analysis. The starting point of what communities are important for us, because in the end, wherever we are, and doesn't matter how big the communities are, we still need to be able to talk about our tasks, our strategies for analysis, for imaging, and so on. And of course, it is also necessary for writing grants and teaching ourselves and other people how to do all these things in a best way. I think since also this this whole event is sponsored by Chan Zuckerberg Initiative. It's fair to start with them because you probably know that they are supporting a huge amount of projects and grants and so on, and they are also writing up grants for creating communities. So together, several set of specific communities were supported. And of course, I'm not able to know all of them, and I'm not able to speak about all of them today. This can be also quite interesting point for you to be able to search for them on your own or a little bit explore if there are some field-specific communities or task-specific communities that you might be interested in. But I will continue with the global bioimaging, which I hope you are definitely familiar with, because this is one of the worldwide communities that is also specifying how the facilities should practice stuff. They are defining what the imaging scientist is, and also in a big part are supporting image analysis and research integrity, and also a bit of traveling. Sometimes one of the best way to learn or practice collaboration is to travel a little bit. I will get to that part too. So for me, or I hope in general, one of the most important communities that I get to was Neobias, which was focused on 4 types of expertise. For life scientists or biologists to be able to set up or ask question and answer about their experiments, the instrumentalists or microscopists to develop and discuss how to get the data and collaborate, and the developers, so whoever is creating new tools, new algorithms, so computer scientists where I can a little bit get to, and people that create algorithms and validation. And of course also the bioimage analysts, which as a name or as a person wasn't set up that much before. So it was also important to set up the position of the people like this. So to get some people that are able to select the appropriate approach to validation and assemble all these subtasks. And of course, like one of the most important part and task of this community is to promote the mutual communication between these communities, because that can ease up and speed up the whole part of the image analysis in life science. Because if we can improve how we control and the ease of control of the microscopes, then of course the other tasks will get easier and easier. And out of this community, there came out a huge amount of sustainable material focused on training and bioimage analysis. For me, like this is still one of my one of the favorite channel for the talks and tutorials for specific tools. If you are thinking about learning about some very specific bioimage tool, then I really recommend to look at the Neobias Academy YouTube channel first, or one of the defragmentation training schools records, because they can provide you a very nice step-by-step approach and overview of what the tools and what tasks they can handle. Of course, like a lot of the open source software has incredible documentation with step-by-step tutorials, with videos, and even some reference projects and data too. But a lot of time, like this is the easiest and the fastest way how to get to know a little bit about the tool as it is. Of course, like one of the one of the very nice tools that you might want to get familiar to is the Bioimage Informatics Index, which is basically a search engine where you can look for specific plugins and tools by writing the keywords. So it actually doesn't matter whether you are a bioimage analyst or a biologist. You can just explore and see how many options there is for the specific tasks. Because of course, if there is something, someone have to write it. You might get in touch with them if you want to edit it or find out whether they are doing some training school, and you can get faster to a lot of information. And of course, one of the parts is also the ImageSC forum, where you can get a lot of information about questions that people previously asked. And if you're looking for inspiration of the posters or the slides that are connected to bioimage analysis, the Ad1000 research gateway of NetBS is the perfect way where to search or even post your information. If you have a poster connected to this, you can publish it there with DOI for free. So you can also add information to the community as it is. The next very new thing is the Global Bioimage Analyst Society, which is a little bit continuation of the NeurBS. It's a worldwide association that again try to bring together the bioimage analysis and analysts and to focus on the knowledge exchange between the members, online events, in-person workshops, and also online repositories. It is starting officially this year, and there will be the first in-person workshop this year. Unfortunately, the sign-up option is already closed, but I strongly believe that there will be other opportunities to join or even resources. And I will also show you some of the information and the resources that comes out of this community. But the next one that I already mentioned is the ImageSC forum, which is a perfect way if you like to read or ask a question, perfect place for you to search for. There are several focus areas from acquisition processing, so also image analysis, management of the data, and it is open to everyone. And there is a very big chance that if someone had similar, that someone before you had similar question, you are searching for to answer, then this is the perfect place where to start to look for. And I can tell you that personally, it helped me many times where I was trying to figure out some very specific problem that I encountered. It I found it already answered there, or I was able to continue with a thread. There's also a community part, and you can sign up for getting information and updates from the specific tasks. And of course, the objective is for the independent learning and very inclusive discussion, focusing on the open source software and projects. So you will find there mentions of the huge amount of the open source tools that are existing. And basically, for the guidelines is to learn to communicate properly in this like multidisciplinary world, and ideally post question with representative images and clear explanation. So I believe this can be very good learning opportunity to when you want to publish some of your workflows, to also learn from there how to work with that, how to write it clearly. And I shouldn't forget that this is jointly run by the Broad Institute and UV Medicine through the COBA that I will mention. So this is something that is more closer to you than to me in Europe. So definitely something you want to do. But of course, based on the communities, there can be huge amount of other options. Of course, the global bias, is aiming at putting them all together. Originally, it was called bias, but it is super important to not to forget that there will be a lot of local options, as you have the Latin America bioimaging or the Mexican bioimaging, or you can even, if you will be interested, start some of the local bias community on your own. I was actually inspired by the Swiss bias, uh, which is run through GitHub. So everything is online for free. You do not have to pay for it. They were very welcoming to me in explaining how everything works, how to set up, and how they are operating. So I can extend this also to you. I'm very happy to share what we learned in 1 year of running and starting the check bias. And I will be more than happy if you will be interested in communicate out how all this work, because the option to discuss specific tasks, to talk with other people about their problems in the local setting is very, very important and very nice. So let's continue with the option for tools, because I think you understand that through the communities, through the collaborative work, we are capable of creating a huge amount of tools that sometimes there is too many. So it's good to know in what way to search for them. And one of the best ways, if you do not have access, for example, to bioimage analysis, to help you with this a little bit, to use the bioimage informatics index. It is done and prepared to provide a unification of set of views. So either you can search by problem-based questions, so find nuclei in cells or find specific sector, or the method-based, so segmentation, deep learning, or any other approaches, or tool-based. So if you're familiar with some specific tool, like can be Fidget, then you can search for Fidget specific plugins, and you will be able to find links and explanation that is created by someone specific. And also, if it's possible, the platform is gathering commented links or links as they are. So the database can be also thought as a little similar to Wikipedia. So the community provides the contents, and the content as is there then managed by writers. So if you are not sure where to start, or are looking for specific plugins for some tools, this is very, very helpful tool that are created by community and connected to other tools too, which is actually again the image SC, which has a lot of partners with a lot of tools, and for each of them there are also two specific threads. So you will be able to find the links to already existing workflows or explanation, or even papers, or you will be able to search for the general question. So it is practically very nicely done knowledge base about all of these tools. And for me, when I did see this for the first time, I was like, oh, there's so many tools. If I will have to be able to use all of them, then I will not be able to do my work properly. But sometimes even this, it's not true. Because for a reference, I did highlight it, the tools that I am working with, or at least a little bit familiar with. So you can see that I definitely do not know what all of the tools there. That I'm familiar only with a subset of them, maybe something like 20%. But again, since I have an approach and I know about the communities, the forum, then I always have access to someone that is helpful and someone that can point me to a direction in case some user will come to me and ask, okay, so I have this super nicely done plugin done is this and this tool, but I don't know how to start it off. Can you help me? Then again, I will probably start here at the images to search for this. And that's not all, because there is a very nice paper, A Hitchhiker's Guide to the Bioimage Analysis of the Universe, that is actually written also by Robert Haase, that was presenting here. And it is very nicely putting together all the tools and the glossary and the approaches in a way that you can, in very easy way, find out and orientate yourself based on the workflow templates or workflows as they are, and it can speed up your approach of setting up and testing the bioimage analysis workflow that you need. And also, it is referring to some of the other published and curated lists of software, specifically for the quantitative plant analysis, microscopic hardware, the light sheet microscopy, and cryo-EM. So again, that can be very helpful if someone in the community already set up a list of the tools that can be helpful. Then it is very nice starting point for you to search through this and find out whether someone didn't already made some approach that would be useful for you. Another, let's say, database or coordination, you might have heard about the microscopy DB or the microscopy databases. The aim is to create one global database with the microscopic related content. So if anyone adds some information about the link to education materials, jobs, events, and so on, you will be able to find them online. And it works in a way that when you partner up with the microscopy DB, you will be able to place the specific, let's say, search part on your web page. So if you are interested, I definitely know that Bina has one, or Czech Bias has one, or if you search for microscopic DB, you will find a full set of the current partner that are using some of these parts. So again, you don't have to place a lot of information about a set of web pages that something is happening, or you are preparing events, or when you will want to start to search for some resources, you can very nicely do it through database like this. I think every one of us is very interested in the AI in the life science. So I also wanted to mention the AI for Life project, even though it's not specifically community, but I think the community will grow around the AI-based and the state-of-the-art models. And the AI for Life is specifically bridging the gaps between the very rapidly developing field, and is providing with the services and infrastructure and models that will ease up using these tools. So even though, as you've seen on the slide, they are European specific, they created something called Bioimage Model Zoo, where there are examples of deep learning and machine learning models that you can test with data and with code. So the life scientist, it is very good resource for the models. For the computer scientists, this is very good way to share the model and the working example. And for the core facilities or imaging science, this is very nice way to get support, to look at the training events, and to learn about the services. And the bioimage model zoo also provides a set of tools that you can run it with. So there's PG, if you are familiar with Elastic, Enjoy, and more. Or you can actually try online some of the approaches in the bioengine. So I see it as a future for all these tasks, that we will have some repository with a very easy way how to test up the approaches and go fast test whatever these things makes sense to use on our specific data. And sometimes we do not have also access to the resources where it would be possible to run these models or tasks. So I also wanted to mention two ways where it is possible to get either to the resources and the tools, or to way how to speed up a starting of approach. So I'm not sure if you ever heard about the bioimage analysis desktop bench run by MBW, but it is open access cloud-based desktop where you can ask for a specific set of CPU, of RAM, of GPUs. The time is limited, but there is pre-installed software as a Fiji, Cell Profiler, Cellplo, Snapari, and so on. So also sometimes it can be really hard for us to start and make work this software. So this can be a very nice way for learning, teaching, or testing out some of the approaches. I think there will be always someone that is more skilled, more technical. So I also wanted to mention that there is something called Bio Desktop, which is prepared virtual computer that you can run on a server or your own computer, and it can without a need for a specific hardware installation run very similar environments to the bench anywhere you like. So it's for the developers, it's very easy to version and build the tools on point of that. For the IT point of view, it's a very simple way to download it and run it. And for the users, it's like a computer with everything installed and running that I can use. So I thought that it might be also interesting to mention that something like this exists, because again, like there has to be a lot of people putting information and resources in the community together to make it work. And you might be thinking, okay, so a lot of these things are difficult for me to do, or to even get approached for this, I will need a help. And of course, the collaboration can be very useful part for this. So I thought also that I will be mentioning what the collaboration can be for, and how can you benefit, and where to search for information like this. So depending on what you are thinking, whatever it is consultations or specific surveys like the code writing review or the analysis or teaching, there is always some options. And there's always some communities that will able to provide some options for you. For example, the Global Bioimaging also provides job shadowing, which I find out very useful, because the benefit is having a dedicated time to focus on some specific tasks. So you can learn more effectively. You can get more time to focus on some things. But sometimes you don't have an option to do this or you don't have the time. So it is good to know how to search around you or in the world for the core facilities or the groups that are focused on the bioimage analysis as a service. So you either can be able to find a core facility or a hub or even a development group that can help you, where the core facilities, from my point of view, might be very or bring a better benefit, because each of the core can be specialized on some specific imaging approach or have a specific microscope. So they will definitely have this specific or specialized knowledge about working with the data. Or in general, you can look at the bioimage research infrastructure, as are the bioimaging, Eurobiomaging or the local ones. But what I wanted to emphasize, if the facility provides the technology, like the imaging technology, they will also know how to analyze the outputs. So that would be definitely a good point to start. There might be projects or facility that also provides open access calls. So there will be definitely more, but I know, for example, in Czech Republic, we are having a calls for bioimage analysis that is open to the whole world. There is a limited funding, but still, like it is possible to do. The French bioimaging have very famous image analysis hub and are, I believe, are very open to collaboration. And for example, connected to the deep learning, the AI for Life have open calls. I'm not sure if they ended, but hopefully not. So that is also very useful thing to know. But what I also wanted to mention is that the communities as Globias now has the database of self-listed people that are organized in the trainer and analyst part. So for example, if you will be searching for someone to teach you something or for a workshop, there's already a list of people that are listed and with information what they are capable of doing, but also a set of analysts that can provide a specific support or service for you in specific tools or as a consultant to help you out, which is, I believe, very beneficial if you do not have the general access. What did I find out that can be very close to you is the Center of Open Image Analysis, so in short, COBA. Of course, they are again specialized on something of the technology that they are using, but I think it is good starting point. Also, if you work with or want to work with Cell Profiler and ImageJ, and also they're focusing on some of the deep learning tools. They also provide like kind of three sections. So first is research and development projects focused on the deep learning workflows about accessibility, of course, fostering a community. They have some biological projects with Hub, and they also focus on training the community as they are. But also they have a lot of training materials, workshops, hackathons, conferences, and support for facility staff and their own softwares. There is definitely also the image analysis collaboratory, where I believe they also do a very good job and focus on workshops, but it is also good to learn and find out how available they are. So that did take me to the end of the talk, and I wanted to thank you for your attention, and also I wanted to thank you for being part of such a great community, because at least me personally, I wouldn't be able to do my job properly and enjoy the inclusivity and the help that I'm getting in every part of the world, because I found out that everyone is very, very, very welcoming and very happy to help me or help anyone around. So, if you have any questions, then now it's a good time for them.
Thank you for this really useful presentation, Doctor. So many recurs he don't know about the different topics. He also topic this presentation will be interesting of help for the audience. The question of the audience is, had you started that information with college communities like EBS schools that have a special focus in science?
Can you please repeat
Yes.
it?
Had you started that information with college communities like EBS schools that have a special focus in science?
You mean like a specific focus? Maybe I don't understand the questions properly, because usually we try to share as much as possible, be inclusive. That was the point.
Okay, don't worry. The question is in the chat.
Okay.
Yes.
The college communities. Okay. I mean, every college can have their own, but I think this is like very specific to a country and to a university as it is. So usually, I think every one of us are trying to share this or share that we are doing a workshop. But in the end, it depends on the local organization. Because, for example, I am coming from university. When I started studying as in a bachelor degree, we didn't have support for any kind of community. And in the set of years, it improved, and now we have specific communities from anything from brewing beer up to presenting knowledge, exchanging information with other schools, and so on. So I'm pretty sure that there will be like a huge amount of them. I will definitely not know about most of them, but I'm very happy to share. If you have some ideas where to share the information, I will very happy to do so.
Thank you, Doctor. Thank you for your time and your possibility to join us. And thank you so much.
Thank you too.
And we have a special thank you from Dr. Vadim, that is in Mexico City. He's very excited with your presentation. He says it's something that he didn't know, and he's very happy that you are sharing this with the audience today. And he hopes to see you soon in an event in Mexico, in other parts of the world. Really, really happy. Really thanks for you, Martin. And yes, you are always invited to visit us in any part of Mexico.
I think I would be. It would be very nice to do so, and I'm happy that you are happy with the presentation, and I hope to see him soon somewhere in the world. And thank you again for inviting me.
No, we are very, very satisfied and happy because it was really, truly amazing. And if it's possible to share with us the presentation so the audience also can check again the information, be amazing.
Yes, I will.
Yeah, so thank you, thank you. If you want to stay, we are going to have a quick coffee break now, and we'll be back with the presentations in Mexico. So they are going to share with us their screen and presentation. So we are going to be now audience for them, but you are invited to stay with us the rest of the day. The same for Robert and Adan that are also with us right now. And that's it. So guys, we are taking this coffee break now and we'll be back in 15 minutes. Regresamos en 15 minutos después del coffee break. Gracias. Thank you. Dobry den. No, dobry den is it's other thing. Dziękuję. Dziękuję. That's it, right?
Yes, very good. Yes, yes.
Okay.
Thank you too.
Bye bye.